Tamara Avellán is a sustainable water specialist with a background of biology, limnology, physical geography, wastewater treatment plant management, and she worked mainly or a part of many expertise on the water, energy, and food. She has a background of MSc in biology from the United States, a PhD from Germany, from the Ludwig Maximilians University, habilitation from the TU Dresden. She has a wide range of experience from working in Europe, in Latin America, in Asia, for the World Meteorological Organization in Geneva, for the United Nations University in Flores and Dresden. And she was a core for building up a lot of initiative, one of them for the World Meteorological Organization, the Global Framework for Climate Services, and also building a department for the UNU Flores. So this is a small part of the introduction for Tamara. Please, Tamara, you can start your lecture. We will be happy to listen, and we'll be also happy to answer some questions later from the participants. Thank you.
Thank you, Firas, for these kind words of introduction. So today I will be talking about nature-based solutions and their role or relationship to sustainability, and in particular to sustainable water management. I have partitioned the lecture into 3 parts. So we will be starting with some words about sustainable water management and what that might mean. Then I will tell you a little bit about nature-based solutions and in particular constructed wetlands, which is a nature-based solution that I've been working on quite a lot. And then we will finalize the lecture by looking into sustainability assessments and what that might mean and how that might relate to nature-based solutions and water management. All of this is based on work that others have been doing, obviously, but also work that I've been doing in the past 10 or so years. So sustainability is the concept that is very strongly related to sustainable development and has quite a long history. Most of you might be familiar with the definition of the Brundtland Commission, which is the one that you've got at the bottom, that humanity has the ability to make development sustainable, to ensure that it meets the needs of the present without compromising the ability of future generations to meet their own needs. So the concept of generational justice. And you can see on the timeline the different events and highlights that have been happening over the past 40 or 50 years. In particular, 1992, the Rio conference and the conferences that have happened since then, the Millennium Development Goals in the early 2000s, and then the Sustainable Development Goals in 2015, which we're still currently working on and trying to achieve. And on the right-hand side, the important part is this, what I call the trifecta, the 3 elements or aspects of sustainability and of development, the economic aspects, the social aspects, and the environmental aspects. And if we want to achieve sustainability or sustainable development, then all of the 3 pillars need to be worked on. We cannot simply only work on, for instance, the economic aspects and forget about the social and the environmental parts. Then we will have environmental degradation and social uproar. So this is then challenging. So all 3 parts should be coming together in order to achieve sustainable development. And as Firas mentioned, part of what I've been working on in the past decade is what is called the nexus or nexus thinking. The water, energy, food nexus is the most prominent one here. And the idea here is that in order to work towards sustainability, these three elemental human securities need to be obtained: food security, water security, and energy security, which is what we see also reflected in the SDGs. And these securities are under pressure. They're under pressure on the one hand from global changes like climate change and biodiversity loss, which degrade the natural resource base, which is needed to feed these securities. But at the same time, they're also compromised by social changes, such as demographic changes, population growth, changes in habits, such as diets. As soon as people move from the countryside to urban areas, we know from research that their diets change to much higher caloric values. And those then again provide pressures onto these securities. And so what the Nexus tries to do is that it looks at how to optimize the relationships between food, water, and energy, the so-called interlinkages, in order to reduce friction and to optimize resource use between these three elements, and therefore relieve in part the demand on natural resources, and also still provide to the social needs that come from the population, from humans. And of course, this is limited. So I know that Johan Röckström had his first lecture in this lecture series, and maybe some of you were part of that lecture series, that lecture he gave, and Johan talks a lot about planetary boundaries. And planetary boundaries are exactly looking at how much natural resources can we produce, or are there, how much of that is available for human use and consumption without harming the environment. So we're not the only ones that need natural resources. There are other beings, living beings on this planet that also require natural resources, and we again depend on them. And so the concept of planetary boundaries is also very important for this nexus approach. And part of what the nexus approach then tries to do is that it looks at the governance and the policy aspect. So all of these securities are also interrelated in terms of policies. We govern things like agricultural production and energy production and water allocation, and all of these are cast into policies. And making sure that these policies actually talk to each other and aren't in conflict is what, with the Nexus approach, we're also trying to do. And there are many projects out there. For instance, Nexogenesis, which is a project that I am part of, where we look at exactly that. What kind of policies do we need to have in place to reduce the demand on natural resources and to optimize resource use for these three securities while still safeguarding the environment and environmental needs. This you might be familiar with. The Dublin statements on water and sustainable development are basically, these are the baseline principles for integrated water resource management, IWRM. And there are four important, there are the four main principles. And the first one is that fresh water is a finite and vulnerable resource. And I think this one is really critical and very important because we often forget that there's only this one planet and there's only so much water. We open the tap and the water runs. We flush the toilet and it goes away. But it's finite. And the graphic on the right, you might have seen this one in your classes and courses before. Most of our water on this planet is held in the oceans. Only 3% of it are usable as freshwater source. Most of that is stocked in ice caps and glaciers, and a third of it in groundwater, and only 1% of that 3% is available as easily accessible fresh water in lakes and rivers and in soil moisture. So important to take care of this finite good that we have. The second principle is one that is very close to my heart because I work a lot in participatory management, is that water development and management should be based on a participatory approach involving users, planners, and policymakers at all levels. This is really critical, but very, very challenging. As soon as you bring different stakeholders around the table, they all have their different interests and needs and wants and levels of knowledge and levels of capacity. And to then align interests and figure out how to work together towards sustainable water management is not always easy. It's actually very challenging. The third principle is that women play a central part in the provision, management, and safeguarding of water. This was considered really critical and key in 1992 to highlight this gender aspect and to really put women at center stage for water management. But often, and this is why I put this picture here, this is really what we think of when we think of women in water management, is women fetching the water. But there is so much more to women and being part of water management by putting women into positions of power and making decisions. This is where we would want to see women, not just fetching the water. And the fourth principle was very controversial and still is, that water has an economic value, and that its uses should be recognized as an economic good. So this is often, so there's two thought lines about this. The idea why this was put in here was that if something doesn't have an economic value, if you don't pay for it, you don't value it in the sense that you don't take care of it. So this was the idea. If we give this an economic value, then people will start caring about it. If you open the tap and you don't pay for the water that you consume, you will just let the water run and not think about where it comes from, what it took to produce the water, to get the water to you, et cetera, et cetera. The flip side to the economic value concept is that this means that water can be sold, and that water is then an economic good and is no longer a common that we all share and that we should value because it's important to us, because it's the base of life. And that is then when the thinking of, for instance, Coca-Cola tapping water in developing countries to then produce soft drinks, to then sell those soft drinks, or even just sell water also, becomes the negative flip side of the economic value concept. So there's these two ways in which principle number 4 has been discussed very critically over the past decades. Water is important. It's an SDG. I put here the icon of SDG number 6, clean water and sanitation. And I also brought you here the latest number of one of the goals of SDG 6, one of the targets, sorry, and where we stand. So this is what you see at the bottom. In 2020, globally, 44% of household water was not safely treated. So we have 44% of the global population that does not have access to safely treated wastewater. And you can see on the map on the left-hand side that all of the countries that are in this reddish color or yellow color are below 50% of safely treated wastewaters, and the gray countries are that haven't provided sufficient data. I currently sit here in Uruguay. This is where I'm delivering this lecture from. And as you can see, it's gray. And it doesn't necessarily always mean that they do poorly. Uruguay actually has a fairly high percentage of safely treated wastewater, but not all of the countries provide their data or provide their data on time, so that we then don't always have a complete picture of what's going on globally. You might know this, but just to recap, how do we get from surface water or groundwater to the tap water and then back again into surface waters with the treatment systems? So first we treat the water that we take from any kind of water source, be it surface water or subsurface aquifers, through flocculation and sedimentation and filtration, and then disinfection before it then gets pumped and distributed to the population. And then all of that goes back again into a wastewater treatment facility, where you have basically the same process again. So you've got some sedimentation, digestion, and then some disinfection and clarification before it's being discharged into surface or subsurface water system. So we do this process of cleaning basically twice, once to consume it and then another time to put it back into the environment. And that consumes a lot of energy. And in particular, wastewater treatment plants consume quite a lot of energy, in particular in terms of the water transfer, but also the tertiary treatment. And what we see is, if we look at the breakdown of how much energy is being used, the biological processes, so the secondary treatment here is what uses the most amount of energy. And we know that globally, the wastewater treatment consumes about 200 terawatt hours, or about 1% of the total energy consumption globally. So if we only have 44% of the household wastewater, if we still need to treat those household waters that haven't been treated so far, then we also know that the 56% of treated household water already consumes 1% of the global electricity need. So where is this additional water going to be coming from, since we also need to focus on reduction of carbon emissions and similar. So the question is, where is this energy going to come from? What about the greenhouse gas emissions? Are there maybe other treatment systems other than the ones that we're currently using that might be more useful? And what about maybe some energy generation through treatment plants, which we know exists, and I'll give you some examples of that. And if we look now at the agricultural side of the water, energy, food nexus, we also see that a lot of water is being consumed in agriculture, and currently 32% of agricultural irrigation water can also be used, can also be from wastewater, treated wastewater systems. So there's a link then also between wastewater and irrigation probabilities or usefulnesses. Now, this is what I call my chicken and egg dilemma, which is, for me, has been my biggest research question in the last 10 years, is that if we want to achieve sustainable water management, and one of the ways of maybe achieving sustainable water management might be the use of treated wastewater, it's the part at the top, then how do we make sure that our wastewater treatment plants are sustainable and allow for resource reuse? Because a lot of our treatment systems, as I showed you, are energy consumers. They take up a lot of space. as I showed you, we need to treat our water twice, once to consume it and once to dispose of it. Is all of this really sustainable, or do we maybe need to think about this differently? And so my take on this is that the way we view wastewater and its treatment must undergo systemic change to provide a chance for sustainable water management and thus water security. And as I told you, I'm a big fan of participatory processes, so Dublin Principle number 2. And in my view, one of the ways of achieving this systemic change is to work in a co-production manner. So to co-produce knowledge in inter and transdisciplinary manners. And let me just show you maybe quickly what I mean by this. So if we start from an unsustainable wastewater treatment and management system here on the left-hand side today, we do need a lot of science to get to sustainable treatment systems. And this, in my view, needs to be done in an interdisciplinary manner. So we may have the engineers, the classical engineers that drive the engineering side of the process. But we may also want to put some social scientists in there to think about, what do the population really need? Do they need a big treatment system, the classical ones that we know of? Is it suitable for the location? Does the location have electricity in a constant manner to be able to provide the electricity needs of those treatment systems that are thought to be put in place, et cetera, et cetera? You can think of many of these other things. And this then becomes the link to the transdisciplinary part. So this is where we work with what are called practitioners or stakeholders in a multi-stakeholder discourse, where the scientists then come together with the stakeholders to be able to understand what are the needs on the ground, and what are maybe also the solutions that have been thought of on the ground that might be more reasonable and more effective, and thus potentially more sustainable than what the engineers have thought of. So this is quite radical, I think. I've had at least lots of discussions with engineers that tell me that that's not possible. But we have seen this in a project that we've done in Mexico and in Guatemala, where this was really quite an effective manner of working together and of coming up with solutions that might work much better long term than what others might have come up with before. However, what is important in these processes is that we understand each other. And people that come from different disciplinary backgrounds don't always use the same language. They don't use the same, what we call jargon. And so in a paper that one of my PhD students at the University of Oulu wrote, this is what we did. So we co-designed common definitions for, in this case, it was sustainability and agricultural water management. This was the concept that we were trying to define together. And so we did what is called a Delphi approach, where we did multiple rounds of surveys and asked the stakeholders about their views on different aspects of sustainability and agricultural water management. And we also asked them to rank these three pillars of sustainability. So the dark is social sustainability, the less dark is economic sustainability, and the light gray bar is environmental sustainability. And in the first rank, you can see that most of the stakeholders that we worked with ranked environmental sustainability as the highest. And this is quite common. This is what we see in a lot of environmental resource projects that I've been working in. that environmental sustainability is really considered to be the most important aspect, which is good. However, what we're seeing, and you'll see this, I think, towards the end of the presentation, is that social sustainability is really quite critical to now achieve what I call social innovation, or not what I call, but what is called generally social innovation. What we also see in these interdisciplinary processes is that information holders, so people that actually have the data, are not the same ones as the decision makers. And the connections between the people that make the decisions and the people that actually have the information that is necessary to be able to make those decisions is not always very strong. So this is network analysis that we did in a project in this, I think, is the example of Mexico. And what you can see is on the left-hand side these are the information holders. It's the network of the information holders. So the big dots are the ones that hold the most amount of information. So these 3 points are the stakeholders that have and hold the most amount of information. But the ones that make the decisions about what will be put in place are the ones here on the right. So you see the big dot are this one, Presidencia Municipal, Sanidad y Salud Municipal, but they're not the same ones necessarily as the ones that hold the information. You do have some overlap here with Camtro and Piavi. So this is good because there are connections then to the decision makers, but not all of the information is then necessarily available to the decision makers, and making those connections is what is then critical in those transdisciplinary processes, so that the decisions that you make are good decisions. And we'll see a bit more about that later on. And decisions really rely on knowledge generation. And as I told you, we come from different backgrounds. Scientists come from different backgrounds. Stakeholders come from different backgrounds. We have come from different disciplines. We come from different cultures. We come from different ways of thinking, of different ways of viewing the world. We have different perspectives and interests, and we come also from sometimes different political systems. And all of that creates certain ways in which we think, in which we communicate, and making sure that those different actors then are able to work together. This is where you then need those processes like the Delphi approach to understand each other's jargon. You need to create glossaries so that you know, if we use this word, this is what we mean by it. We agree to use this word in this certain manner. Even coming to that point is a process. And this is then what we have termed the co-production of knowledge, and which is what we're using in Nexus projects, where you co-produce this knowledge at various levels within the project consortium, for instance, or within the case studies that you work in, and then also across those different spheres of actors. And you work with different kinds of data and knowledge that is generated on these 3 levels of knowledge: system knowledge, target knowledge, and transformational knowledge. System knowledge being the knowledge that you need to understand the now, where you're at today. Target knowledge being, where do we want to go? What is our future vision? And not everybody might have the same vision, but getting people together and trying to construct this collective vision is quite critical. And then also the transformational knowledge. How do I get from where I am today to where I need to go? How do I get from my system knowledge to my target knowledge? This is the transformational knowledge. What actors could help me? What governance systems, what ways of communication, what ways of working together might get me from where I am today to where we want to go together. And in this Nexogenesis project that I was telling you about earlier, we analyzed this knowledge generation in the stakeholders that we are working with. These are two different case studies, on the left-hand side, case study 1, and on the other side, case study 3. And if we look at which kind of, so the blue is the system knowledge, the yellow is the target knowledge, and the green is the transformational knowledge, we asked fairly in the middle of the project, about year 1.5, 2, we asked these stakeholders what kind of knowledge they have been acquiring through the project, and in particular this one workshop that we did this survey at. And we asked them about these 3 different levels of knowledge, but also particular kinds of knowledge that we had been working with them. So biophysical aspects, social and economic aspects, understanding better the interlinkages between the water, energy, and food aspects, more knowledge about stakeholders and policies. And what we saw is that in all of the cases that we looked at, that in this particular case, stakeholders had acquired the most amount of knowledge in the target knowledge area, and the transformational knowledge area still needed a bit of work. So this gives then the scientists in these projects an indication about which area to maybe work on a bit more, maybe to give a bit more information about, for instance, the social and economic components that were a bit weaker in this these analyses. So this is really good food to then be able to work on further. So for me, sustainable water or wastewater management is really crucial for sustainable development. But sustainability, in my view, will only be achieved if we apply new thought paradigms that really require inter and disciplinary knowledge co-creation. If we now go to the next part about the nature-based solutions, this is maybe something that you've seen before. This is the definition of the IUCN about what nature-based solutions are. This was also a very long interdisciplinary process to come to these definitions. But the point is that you use ecosystem-based approaches to to societal changes to ensure both human well-being and biodiversity benefits. And these can be restoration, all the way from restoration to infrastructure to protection of environmental systems. The IUCN has this definition on the left for nature-based solutions, that these are actions to protect, sustainably manage, and restore natural or modified ecosystems. And the European Commission has a similar definition, which highlight these, again, these 3 elements of sustainable development: the economic, the social, and the environmental benefit. And these are living solutions inspired by and continuously supported by and using nature to address societal changes. There are a number of different categories for nature-based solutions, from ecosystem restoration approaches to infrastructure-related approaches. And these are have been in my research the most important ones. And as I told you, I'll show you a little bit of what I've been doing with constructed wetlands. Of course, for water, ecosystem protection approaches are really important, like closing off forests for groundwater infiltration and protection, but also or river sides, but also things like ecosystem restoration approaches, regreening rivers, more room for the river, improving floodplains and expanding floodplains. All of those are really important for water issues from floods to droughts to all of those things. So for water management, lots of different nature-based solutions are critical and important. I will only be talking about constructed wetlands as one really tiny little element of how nature-based solutions are relevant for ecosystem, for water management. There are these different categories of nature-based solutions, from the very natural ecosystems, so for instance using natural wetlands, to restoring them, like re-wetting wetlands, or creating new ecosystems like putting in constructed wetlands, that go then from a lower to a higher level of engineering, and try to maximize ecosystem services delivery. Now, this is a very anthropocentric view, and nature-based, the concept of nature-based solutions is in general very anthropocentric. We can have a long debate about if this is the right way of going about it or not. This is what, let's say, the community has come up with at the current state. I know that the debate has gone beyond this, and that we are looking into also just leaving nature as it is and giving nature its space without it having to provide ecosystem services to us. But given the nature of this talk, this is about nature-based solutions, and those are there to provide us with ecosystem services. So if I go back to my paradigm of wastewater for sustainable water management, and how to make sustainable wastewater treatment systems more sustainable, you kind of got to look, or this is what I did. I looked at how can I make systems more circular? How can I maybe integrate them into a nexus approach? And how can I thus make them more sustainable? And one of the ways of maybe doing this is with constructed wetlands. Constructed wetlands are man-made treatment systems that use natural processes involving wetland vegetation, soils, and their associated microbial assemblages to improve water quality. And they do this through very interesting processes. If you ever want to build a wetland or want to know more about it, I would guide you to this UN Habitat booklet, which gives a very nice overview of constructed wetlands. You basically make a hole in the ground, more or less. You fill it with rocks, and then you put wetland vegetation on it. And the wetland vegetation is really what makes the difference, because wetland vegetation, also called macrophytes, because they're usually submerged underwater, there is no oxygen in the root zone. So in order to bring oxygen down to the roots, they suck it up through their stoma on the leaves, and then transport it down into their roots, which means that the oxygen then diffuses from the little root hairs into the surrounding area. So that when you then have wetland plants, you create two oxygen zones. You have most of the area which is completely anoxic, so no oxygen available, and then around the root zones you will have a bit of oxygen. So you can then have different microbial communities within this system at the same time. So you will have microbial communities that don't need oxygen and others that do need oxygen. And these are the ones that will then break down the nutrients and the organic matter and do the filtration processes, which is why wetlands in general are really, really super important for our water cleansing in our natural environment. All of these wetland vegetations are critical to maintain good water quality in all of our surface water systems, and are usually also often the ones that will allow for the when you have wetland systems and you have and if these coincide with areas where water infiltrates into the subsoil, these wetland systems will also be the ones that actually clean the water before it goes into the aquifers. So I usually always advise people to not remove their wetlands on their fields, but to actually be happy, because they're the ones that will clean their subsurface water. And in the region that I'm at, we have lots of little hand-dug wells, very shallow wells. So all of our water here is then clean only because of the wetlands that have been left in the surrounding areas. For those of you that are in Latin America, we did a very nice paper on the use of a particular type of wetland species that are salt tolerant called halophytes. And we looked at their properties and their usefulness in South America. And wetland plants are used for lots of different things, medicinal plants and handicrafts and energy production, construction materials. Roofings are often made of juncos, for instance. So lots of different usages. You may want to have a look at this paper. And one of the articles that I wrote a couple of years ago was, okay, so if we have wetland systems, how can we make them more sustainable? How can we get more out of them? And I asked myself then, what is the energy potential from constructed wetlands? And I also asked myself what the irrigation potential is, and what the opportunities and challenges of introducing these systems into a community might be. And we looked at, we did a meta-analysis of articles that were published globally. You can see here the wetland locations all around the planet. This was an English article search only, so you can see that there is very little to actually nothing in Latin America, and also quite little in Africa. But from this analysis, we saw that the energy potential from constructed wetland plants was actually very similar to that of acacia species firewood. And this is a species that is often used in sub-Saharan Africa for home fires, so for cooking fire needs. And for biogas production, which we also looked at, there's very little knowledge about how wetland plants could be used. So there is more research that would be useful here. And if we look at the irrigation potential, we saw that about 55 to 74% of the water that went into the system also went out again. So there is, depending on the plant that is planted on the wetland, more or less evapotranspiration. And in terms of opportunities and challenges, we saw that obviously there needs to be enough water that goes into the system for any water to go out again, and for the wetland plants not to go dry. If wetland plants are used for direct combustion, the burning, like any kind of burning, can cause health problems. So you do not want to be inhaling the smoke. And we also saw that some small-scale biogas productions might be an opportunity by mixing the wetland plants with organic refuse that you have from your kitchen, for instance. And we looked at this in a bit more detail and did some calculations, some theoretical calculations for a hypothetical village in sub-Saharan Africa, and published a policy brief out of this a couple of years ago. And so we said, if we have a village and some livestock and some agriculture and a forest where we get our wood from for the cooking, and we actually put a constructed wetland system into it, maybe even with some sort of small-scale biogas reactors, we can reduce the need for wood fuel to up to 55%, which would equivalent to about 12 hectares less demand for wood fuel per year. We could also use up to 52 cubic meters per day for irrigation. And this would equate into about 1.1 hectares of maize crops that can be planted, which may yield up to 3,500 kilograms of grain per season. So this could then again be put back into the population and reduce and alleviate hunger. So this can be made into a more complete picture and not be just thought of in isolation for wastewater treatment purposes. And this is what I wanted to show with this. So let's think about treatment systems, not just as treatment systems, but as more. What else is it that they can do for us? And maybe you remember the question that I asked in the previous section about the energy gap. And so I asked where the energy might be coming from. And so, of course, at best, this energy would be coming from renewable sources and potentially from biogas production. And we know that biogas production from sludge, for instance, from sludge treatment systems is quite effective and useful. What other systems might be more useful? So nature-based solutions offer multiple co-benefits, as I just showed you, and constructed wetlands are an example of this. Constructed wetlands require only 6.8% of the energy required in a traditional activated sludge system. So very, very little energy is needed for constructed wetland systems in general. And this is probably even only if you're using pumping systems, and if you're not using pumping systems, energy requirements are basically zero. So traditional wastewater treatment systems emit 591 kilograms of CO2 for every kilogram of nitrogen removed, whereas constructed wetlands only use 0.9 kilograms. So this is really a lot less than traditional systems. And so for the sewage, just for the sewage sludge production, it's estimated that current global electricity production from sewage sludge is, so the production of the sewage of the electricity from sewage sludge is about 6 terawatt hours, and that could cover 4% of worldwide electricity needs in the municipal wastewater sector. If you remember, I told you earlier that the wastewater treatment systems currently use about 1% of the global energy needs. And so sludge systems could cover 4% of worldwide electricity needs. They could actually produce this. And so this is really a huge potential that we could still tap into, so that also communities and municipalities might become more electricity neutral. And Vienna, the city of Vienna in Austria, is a really good example of how to do this. Also, Dresden is also a good example. They use the electricity. They use the biogas production from the sludge and feed that back into their sewage treatment system. So concluding this section, then, nature-based solutions such as constructed wetlands provide multiple opportunities for circular reuse and can reduce pressures on natural resources. But, and this is the big but, it's not clear if these are then also sustainable.
I'm sorry, Tamara, to cut your talk, we have 10 minutes left for you because we need to have maybe at least 10 minutes for questions, if this is possible. Thank you.
Sure. So sustainability analysis, to bring you back to the beginning, you do need to kind of make decisions. And this is one of the generic ways where you need to figure out what it is that you're assessing against. So you analyze it, you figure out what your system is at best through participation. You do an analysis of your situation, for instance, with a conceptual map, and then put it, for instance, into a modeling system, where this is then the basis for your system dynamics modeling. Or you do a very complex representation of your different indicators based on the environmental, the economic, and the social dimensions of your indicators, and figure out where which indicators are actually most prominent for which element. But then you still need to choose. And one way of choosing your sustainability is, for instance, here a rapid assessment that we did in the Water Agri project, where we looked at what kind of solutions do we have and what criteria can we draw from the dimensions of sustainability. How do these criteria fit in the different locations where we are applying those sites? And then you get a suitability matrix. You can do this in a more complex analysis through what we're calling a distance to target approach, where you've got some threshold values. You look at how far you are, your actual data from your threshold values, and then you look at your traffic light system, and you then do a sustainability analysis, again, in your 3 dimensions of environmental, economic, and social, and come up again with where you're at in your entire system. You can use life cycle thinking and have an integrated score for your system, again, economic, environmental, and social. And here you can see that even though the economic score is negative, the social score was highly positive. So your integrated score ends up being still positive. You can find out more about this in a policy brief we wrote recently. And so really to assess the sustainability and all its dimensions is really essential for finding the right solutions. And what we saw in a lot of the projects that I've been part of in the last few years is that the social sustainability is an often overlooked dimension, which may hold the key for transformative change. And to then finalize my initial question, if nature-based solutions allow for sustainable wastewater treatment, sustainable water management, sorry, they may, and they're probably our best bet, probably currently in improving circularity and reducing pressures on resources. Sustainability needs to be assessed in the 3 dimensions. The focus in the past has been a lot on environmental sustainability and economic profit. What I would vouch for is that going forward, we look more into social sustainability, and that this transformative change may, I think, need to be achieved through inter and transdisciplinary knowledge co-creation. Thank you. And I'm sorry, I went over time. Jesus, I talked. Sorry, I got carried away.
Thank you so much, Tamara, for a very interesting lecture. I think everybody has enjoyed the lecture. A lot of information which is fits actually all the global centers, the Kaidira Center, the ABCD Center, SAGE in the Middle East, and also the AFAS Center in Africa. We have already received a good number of questions here. Everybody is asking about the possibility of getting your slides. We will then, Petra, I think you wanted to say something.
No, it's okay. Thank you, Firas. Just go ahead.
Thank you so much. Okay, then maybe I start with to have a question from my side. As you already explained at the beginning, that regarding the Dublin, what's called the Dublin Statement of Water and Sustainable Development 1992, where they have all these focus on 4 elements. but they have already missed a lot from 1992 from what we have now from problems. Do you think now with these sustainable SDGs, we are also missing something for the future generation that we are now in this stage we cannot see in terms of water and sustainable?
Most likely. I mean, these are, I mean, and particularly the global processes that happen at the level of the United Nations, they are slow, which is good. They are democratic processes. The 190 plus member states need to agree on moving forward on certain decisions. We see this for the ones of you that have been following the climate COPs, how challenging it is to get those communications out. So what we're seeing in science, we're probably 10 years ahead than what then is being implemented on the political agenda. And for instance, part of the questions that the research questions were asking 10 years ago, they're in some part already obsolete, even when we're answering them now. So the water agri project, for instance, that I was showing you, was trying to solve water and nutrient retention issues in agricultural fields in Europe. But by the time we started implementing the project, we saw that climate change was already so strongly happening in Europe that you don't need to do water retention anymore if you've got severe droughts. There is no water to retain because it's not raining. So I think two things. One, climate change is happening more rapidly than we thought it would, and it's hitting, in particular, Europe and developing countries now that might have thought that they would not be hit as much, or that they would be better prepared. And they're realizing that that's not the case. I think the European risk report from a couple of weeks ago shows that very clearly. And at the same time, I also think that what I said before, that we're not, that we're viewing nature and biodiversity as something that is there to service us. And we have, but nature is more than that. And other people and other communities, in particular indigenous communities, have other views on what nature is and what it should be doing. And so those are really the two things that I think are critical. And this is, so to go back to your questions, the SDGs are also looking at nature and at all of this as an ecosystem service to us. We're looking at SDG. The SDGs are really completely human-centric. And this is probably one of the biggest criticism to them, is that they're there so that we as a human race are okay, but we're not, we're going to be safeguarding the parts of nature so that it can service us, but not because it should be maintained as such.
Thank you so much, Tamara. I think then I will go now to the questions. We have a lot of questions. Hopefully we can at least answer some of them. There is a question from Juan Pablo Gomez. He is asking about the data, because many countries, they are considering still the water data as a classified data. They don't want to share it. So most of the studies, they don't fit what's exactly happening in reality. Some part of the problem, there is already a problem with the data itself. There is no enough data. There are no stations to collect data or data sources. From the other side, there are some countries, they have the data, but they don't share it. How this could affect the natural-based solution topic?
So there's data sharing at different levels, right? So if we talk about data sharing, like the one that I showed you for the SDGs, countries will share their data in a way that is useful for them. So either they will make themselves look better because that's what suits them at the current state, or they will make themselves look worse because they may want to get some funding through that. So this is known. We know that the data that we get in global analyses is usually skewed in one or the other direction, but that's still giving us an overview. We also know that Europe doesn't share all of its water data, for instance, which they could, but they don't. Then you've got sharing of data for instance, scientific purposes. And that really, I always say, yes, it is publicly collected data, and yes, you've paid for it through your taxes, so you should be able to access it. But probably, you know, it took a lot of resources to get it to where it is now or where it needs to get to. So what is it that you will return as a researcher to this agency so that the agency can work better in the future? And we've had good examples. I've had students that, for instance, then gave courses to, in particular, natural meteorological services on data quality controlling and similar, and then you actually get access to the data. So it's a give and take. The data question is a huge question. I think we would need like a whole seminar series on it, not just one webinar.
Totally
I mean,
correct.
It's an essential question, but there is no easy answer to it. It all needs to be interpreted, I guess.
Thank you so much. There is another question is about do the wetlands remove other pollutants and nutrients like nitrogen, phosphorus, or only organic matters? This is a part of the question.
Yeah, so constructed wetlands are quite good at organic matter and nitrogen. They're not so good for phosphorus. They're quite good for heavy metals. Also, they're actually also quite good for retaining antibiotics. They're actually much better than traditional wetland systems, like one of our colleagues from TUD found out. We had a whole project on this. So they are very good for lots of different things. But I always say you can't just put them in place anywhere randomly. You really need to know what it is that you're doing. Do take consultancy companies in and for the design. You do need to know the content of your water quality. How does it look like before you can design it? And so it is a nature-based solution, but it's still an engineered nature-based solution. So you do need an engineer to help you figure out what to put in place. Just because it's a couple of plants, it doesn't mean that you're just planting a flower bed.
The second part of question is about the most of the time the wetlands take big areas, and do you have any suggestion or solution for wetlands where you don't have much space?
Yeah, there's lots of different solutions. So you can also then have more sophisticated systems. They're usually then aerated. Then you can have higher nitrogen removal rates, also better phosphorus removal rates. You have wetland systems that are on facades that provide green roofs. You can put them on rooftops, in terraces, etc. So there's lots of clever ways in which wetlands have been put into small spaces, but they do take up more space than other systems. However, they're as big as lagoon systems. So, yeah.
Thank you. I think there are 2 or 3 questions about what's the effectivity or the quality of the wetlands in the very dry areas where you have high temperature, especially in the MENA region, where it's sometimes the water evaporate directly. Is it, maybe you can give a few words regarding this topic?
This is a good question. So you then want to use plants that will have less evapotranspiration rates. Yeah, so if you have big leaved wetland plants, they will have higher evapotranspiration rates than smaller leaved plants or aphilic, so no leaves. There are ways in which you can work with this, and again, it's a design question. You will then probably have no outflow, which is fine. If you don't need any, that's cool. If you don't, we're not going to be irrigating. That's not an issue. We actually have the largest constructed wetland areas in Oman, where they're being used for the treatment of the petroleum field stuff. Don't ask me exactly, but this is they're being used for that. And so they are in super dry areas and super hot.
Thank you so much. There is also another question is about, is there an average budget for establishment constructed wasteland? Let's say per hectare. It will help them to determine whether natural-based solution cost effective and can be used.
Yeah, no, that's, yes, I've had this question also before. It really depends on where you are, what material you're using, what kind of wastewater you have, how much, etc. So there isn't really a cost X euros per hectare. It depends on the location, and it depends on how much it costs you to pay people mostly. But we do see that the cost for construction is higher than the cost for maintenance and operation. And if you go to the policy briefs that I mentioned before, we do have some costs in there for European wetlands in agricultural systems.
Thank you so much. And there is another question about what kind of models can use effectively in sustainable analysis.
So the most traditional analyses or assessment that is used are life cycle assessments. Life cycle assessments are, they have ISO standards behind it, so they're very standardized. You've got databases behind it that are also standardized. So those are probably the most commonly used systems to assess sustainability, but there's also lots of different other systems, lots of different other assessments that you can use. But the most commonly used are life cycle assessments.
Thank you. I think maybe the last question, what kind of trees species can be used in wetlands?
Actually, poplar trees are used quite often in wetland systems. Those are then used to remove water. So you do not use these in dry areas. You use these in wet areas. And they also bioaccumulate heavy metals. So poplar trees are used very often to remove heavy metals from contaminated soils that also often in like standing water or similar. So poplar tree.
Thank you so much, Tamara, for the interesting lecture and also for answering all these questions. And if you have any other questions, then you can write us directly on the ABCD Center or to the DAAD, and then we will be happy to answer your questions later. Thank you. I will head then to Petra to close the session.
Thank you very much, Firas. Also, thank you very much in the name of the German Academic Exchange Service to you, Dr. Avellán, for the exciting lecture today, and also to the ABCD Center and specifically Dr. Janabi for chairing the session today, and also to all the participants also for the very interesting discussion today. As my colleagues just posted in the chat, the recording of the lecture will also be found within a few days at the DAAD YouTube channel and on our homepage later. If you missed a part, for example, you can watch it there. And also a big thank you, of course, to my colleagues Hanna Cornelius, Britta Nowak and Rebecca Matzinka for organizing the lecture series and also the event today. This event today was the last session of our current lecture series, and if you missed one lecture series, you can also find the other series at the homepage that the link you will receive. So I wish you all the best and a pleasant day today, and hope to see you soon on another occasion. Goodbye.